So here we have the square root of x and the graph of x minus 2. So one is a square root graph, the other one is a line. Again, we'll color code them, so I'll make g of x blue, f of x in green. So for part A, for f of x, the domain, well, square root of x has to be positive. X is greater than or equal to 0. The range, again, this is going back to our first chapter, chapter 3, and thinking about all of our parent graphs. And you should have an image of the square root of x graph in your head, and you would know, oh yeah, the range is greater than or equal to 0. For g of x, it's a line. So our domain is everything, and our range is everything. And now we're going to do the quotient. Again, just off to the side here, draw a picture of both our blue graph, which has a y-intercept of -2 and a straight line with a slope of 1, and our green graph, which looks like this. They might actually intersect at 4, 2, do they? Yes. There's the point. Perfect. Wonderfully drawn graph. Can you see that both of them go through the point 4, 2? I was just drawing a sketch, but then I wanted to be a little bit more accurate. So now our quotient graph is f of x divided by g of x. We want to write an explicit equation for that. So for part B here, q of x will equal f of x was the square root of x, and g of x was x minus 2. And if we were thinking about graphing this, so on my graph there, a reminder that the x minus 2, that's our green, no, the x minus 2 is our blue graph. The square root of x was our green graph. So it's okay when the green graph is equal to 0. So right here, when I do 0 divided by -2, I'm going to get 0. At x equals 1, I would have 1 divided by -1. That would equal -1. At x equals 2, can you see the blue graph has an x-intercept? And that would mean we would be dividing by 0, which is a non-permissible value. So at x equals 2, you're going to have an asymptote. At x equals 4, they're both the same. So what happens then when you divide two things that are the same? You're going to get 4, 1. Now, if we go to our graphing calculator, because it says determine its domain and range. Again, the domain is something that you should be able to figure out easily without having to use your graphing calculator. First of all, we know that from the square root, x has to be bigger than or equal to 0. Basically, all you're doing for your domain is looking for your non-permissible values. You can't take the square root of a negative, so x has to be bigger than or equal to 0. Do we have any other non-permissible values? Yes. We can't divide by 0, so we also have to list that x can't equal 2, because that would cause us to divide by 0. Now on the graph off to the side, we started doing some points, but after doing 3 points, can you picture what the graph is going to look like? Probably not. Not easily. So often for the range, we do have to go to our graphing calculator to see what does this equation look like. Go to y equals, and you can type in the square root of x over x minus 2. And hit graph to see what it's going to look like. We already knew there was an asymptote, and we knew a couple of points. Now that we've graphed it, we can fill in, oh, this goes down like this goes up like this, and it appears to approach an asymptote at y equals 0. You should be able to tell, though, that it doesn't cross that line. Can you see that both after x equals 2, for everything larger than x equals 2, can you see that both the blue graph and the green graph are both positive? And a positive number divided by another positive number will still be a positive number. So in that section, it could never cross y equals 0, because it would never be negative. So now looking at that, what does it look like our range is? Well, it looks like it goes down forever. We have an asymptote at y equals 0, but right here, it equals 0. And then it starts on the other side and goes up forever. The range of this function is everything. Questions you can do for this one are 6, 13, and 16. And we'll take about 5 to 7 minutes to work on those.